So again, I say I don't have my document camera, so we're going to do this as best as we can. This is where we got to yesterday. It says a box contains 2 red crayons, 6 blue crayons, 5 green, 9 yellow, and 3 purple. I'm trying to wait till it's not lagging. Crayon is drawn at random and replaced. Then another is drawn. Find the probability. And remember yesterday, the one said replaced up here. This one is not replaced. So here, remember, we kept that same total number on the bottom. Here, since it's going to be not replaced, that number is going to decrease. So let's look at an example. And guys, I'm trying to hold this still, but I'm a shaky person, so this is kind of hard. Okay, it says the probability of a yellow, then a green. Okay, well, we know there are 9 yellows, and there's a total of 25 to begin with. So out of the 25 to begin with, there's 9. There's probability that a 9 out of 25. Then it says a green. Well, there are, remember we times it together, there are 5 green, but now there's only 24 total, right? Because it's not replaced. If it said replaced over here, then that number would be back up to 25, but it's not. So make sure to watch out for that. And again, you multiply straight across. When you do that, you get 45 over 600, and then that will simplify down to 3 over 40. Okay, the next one, it says probability of both blue. There are 6 blue, so 6 out of 25 to begin with. So we take a blue out. How many blue would be left? Only 5, right? And only 24 are left. So if it's asking for the same color, you have to take into consideration, well, I already took one of those out. So that's why that 6 decreased to a 5. Then you multiply straight across. And that's 600. So that will simplify down to 1 over 20. If you have questions, again, on any of this, let me know. Okay. So this is talking about the bias, unbiased. I'm going to run through this real quick. It says a high school is conducting a survey to see how many students have part-time jobs, determine whether the samples are biased or unbiased. Explain. Okay, the first example is 5 random students in each homeroom. Is that biased? I just randomly pick students out of each homeroom. I would say that's unbiased because it's random. The ages would vary. They don't say, you know, each homeroom of the 10th grade or anything like that. The next one, though, it says every 10th student that enters the high school football game. And this is a typo in their work. This is supposed to say grader. So every 10th grade student. They messed that up. So every 10th grade student that enters a high school football game. Is that biased or unbiased? I would say that's biased because you're only asking 10th graders. And this one, 100 random students in the school parking lot. Biased or unbiased? Unbiased. It's completely random. You're going to get people of all ages, genders, races. So for these biased and unbiased, basically the only time it's going to be biased if it's like asked for like a specific thing, like here, the 10th grader, or if it said all females or anything like that. Okay, let's look at this chart. It says the bake shop surveyed a random group of customers to determine their favorite type of cheesecake. Results are shown below. It says, what percentage reported raspberry truffle as their favorite? So to find this, we simply just do like the probability. So how many said raspberry truffle? 12. So I'm going to write 12. And it's a total of 120. If you add up all these numbers, it's going to be 120. So just like normal probability, right? 12 out of 120. And Desmos is what y'all will probably have to use if you don't have a calculator. But 12 out of 20 point time. So there's a decimal. How do we get decimals into percentages? Times it by 100, right? So 10%. Okay, and it says what percentage reported red velvet or peanut butter fudge. So we would add the peanut butter fudge and the red velvet together. When you add those numbers, you get 34. And again, it's 120 as the total. And then all you do is put that in the calculator. So 34 divided by 120, you get that decimal, times it by 100, because to get a decimal to percent, guys, remember you times it by 100, and it's 28.3. So the next question, it says, out of 800 people, how many would you expect to say their favorite cheesecake is cookies and cream? Well, we know out of 120 how many would say it, so we can come up with like a ratio, right? So out of this cookies and cream, it was 25 out of 120. So we want to know how many out of 800 would say that, right? Hope that ratio makes sense. Put the totals with the total. We have 120. We want to know 800. We know 25 said out of this. So how many would say out of this? And you cross, you'll hopefully remember this, you cross multiply. So this would be 120x equals whatever 25 times 800 is. So 20,000. And then to get this x alone, it's being multiplied, so we need to divide. So x equals about 167 people. Okay, so now we're moving on to the measures of tendency and range. These take a long time because you have to punch in the calculator. So I'm just going to run over what each of these mean. And then because this should be the easiest part of the test is mean, median, mode, and range. So they're always going to give you, I'm sorry, y'all, I know it's so shaky. They're always going to give you numbers, obviously. The mean is the average. So I would, hold on, I'm going to try to make it better. So mean, I would add all those numbers together and then divide by how many I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 15 of them. I'll quickly do the math because I have it right here, but taking time to add all that up, I would never get through with the study guide. So if you add all those up, that's what you should get. Divide it by the total number of 15, and that's when you would get 92.4. The median, you have to put these numbers in either least to greatest or greatest to least. Not going to do that. But the median, when you do that, the middle number, you would mark off, 4, and then mark off 4 from the other side, and then so on and so forth till you got till 1 or 2 numbers. Remember, if you have 2 numbers, you would, and these aren't the 2 numbers because these are nowhere near in order, but you would add them together and divide them. So for the mode now, the mode is the most seen number. So find the number that appears the most. In this case, there's none. There's no number that repeats. And the range, you simply take the highest number, which in this case is 153, subtract it by the lowest, which in this case is 27. And that's the range. So again, I repeat, mean is adding the numbers and dividing them. The average, the median, put the numbers from least to greatest or greatest to least, and then find the middle number or numbers. And then if it's numbers, you add them and divide by 2. Mode is the most seen, and range is the difference between the highest and the lowest. I will give you the answer for these. So you can pause the video if you want and work it to see if you get the right answers. I'll show a good picture of the question. Okay. Pause it if you need. Okay, this one. It says Bella and Isaac take a weekly quiz on their math class. Their grades on each of the 10 first quarter quizzes are shown below. Find the difference in their mean score. So what you would have to do, so you would have to kind of interpret the graph. So Bella made 5 100s, 2 90s, 2 70s, and 160. When you add those up, you would get 880. And that was 5, 6, 7, 8, 9, 10 scores. So her mean is 88. That's Bella. Okay, so Isaac made 3 100s, 190, 4 80s, and 2 50s. So 810, if you add those up and divide by 10, 81. And it wants to the difference in their mean score. So all you do is say 88 minus 81, and that will give you 7, which is the answer. If that makes sense for everybody. Okay. This says Rick ran 1.7 miles on Monday, 3.5 miles on Tuesday, 9 miles on Wednesday, and 5.8 miles on Thursday. How many miles does he need to run on Friday to average 6 miles per run? Well, I know to find the average, you add up everything, divide it by the number. So I'm going to add up all the times he already ran. And I'm going to let Friday's run represented by X and divide that by 5. And we know this needs to equal 6. So let me just break down what I did. Added the numbers that he got for Monday through Thursday. And we want to know Friday. So I'm just going to let X represent that. I divided by 5 because that's how you find the mean, right? You divide it by the amount you've added. And we know that they want this to average 6 miles. So we need to add up all these numbers. We need to combine the like terms. When you add up all those numbers, you get 25.4 and then plus X and then divide that by 5. I'm sorry, guys. So no, I don't know what I'm thinking. Add the numbers together. Just add the like terms. You get 25.4 plus X, and then multiply this 5 and the 6. So whatever number will be on bottom, multiply that together. And now you just solve for x by, this is a positive 25.4. To get this to the other side where x is alone on this side and actually equals a number, subtract it. You undo addition by subtraction. And so x equals about 4.6. So he had run 4.6 miles to average 6 miles. And I'll show you. So let's add up the numbers that he had. 3.5 plus 9 plus 5.8 plus 4.6 is what we said. Divide that by 5, and he has a mean of 6. So if you get an answer and you're like, I don't know if that's right, just add them all up and see if when you divide by 5, you do get 6. Okay. This is really what takes the longest. Mean absolute deviation. So I hope y'all remember the how to do the mean absolute deviation. You first need to find the mean. You need to find the mean of these numbers. Okay. I'm not going to find the mean. I'm going to write it for y'all, but y'all can go back and see if you actually get this. 37 is the mean. So now I'm going to say, okay, 37 minus 22, 15. 52 minus, I always take the biggest number minus the smallest because you need a positive number regardless. You can say 37 minus 52 and that'd be a negative 15 and just take the positive of that, which is 15. But I just go ahead and say, all right, 37 minus 24 or 37 minus 29 and then 40 minus. So I'm going to write down all the, so you just finding the difference in between the mean and all of the numbers. Luckily, I already have it. 2 plus 5 plus 12. And then you divide that by how many. It's going to match what you divided to find the mean by. And when you do that, you get 108 divided by 12, and that equals 9. You do this one the exact same way. You would add up these numbers. You get 2963. You divide that by 5 because there's 5 numbers. So the mean equals 592.6. And again, you take, find the difference in between these numbers and this number. Pause the video if you need to work it out. Same number as what you divided that by. So the answer for this is 128.9. In this question, it said, would the number of minutes of daylight each day for a month or the number of minutes of daylight for the year have a greater mean deviation? Need you guys to remember, the smaller the mean deviation, the less variation. So if you have a mean deviation of 0, that means all your numbers are exactly the same. So you would have 5, 5, 5, 5, 5. And the mean, or I'm sorry, the mad would equal 0 in that case. Now, if you had like 5, 6, 7, 8, the mad might be like 1 or 2. So you see the difference in that. So would the number be greater for the month or the year? it would be greater for the year because it's going to vary more between a year than it would a month, right? So that's the answer for that. Okay. Box and whisker plots. There's only like 2 of these on the test, so I'm not going to worry too much with this, but what we have to do is order the numbers from least to greatest. So do that at least for this one problem. $30. Okay. So the numbers are from least to greatest, and now we just have to separate them into 4s. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. So what you would need to do, 12 divided by 4, 3. That means there's going to be 3 numbers in each set. So like right here would be the lower quartile. And that would mean 25, the number in between there. Right here is the median. And the number between 28 and 30 is 29. 1, 2, 3, right here is the upper quartile. Y'all should have learned these words and definitions of what I'm saying with the lower quartile, the upper quartile, and the notes when y'all did this. And you find the number in between 38 and 42, which is 40. So now, let's draw this. Okay. 12 is the first number, right? So this is how we graph it. 12 is the first number, so it's going to be like somewhere right there. And it goes until the lower quartile, which we said was 25. Then we go to the median, which is 29. So you do the first number, lower quartile, median, upper quartile, then the last number. That's how you plot the 1, 2, 3, 4, 5 dots. So first number, then we're going to do the lower quartile, then the median, which is 29, goes like right there. Then do the upper quartile, which is 40, and then the 61. This is a line, and this is a line, and then this is a box, and this is a box. We made it to, and this is supposed to like connect. This isn't the best drawing, but it's made it to where this is 25%, this is 25, this is 25, this is 25. So everything equals 100. So over here, we said the minimum was 12, the lowest number, the maximum was 61. Lower quartile, we said, was 25, median 29, upper is 40. I'm going to pause on this one right here, so in case y'all want to pause it and work it, then I'm going to give y'all the answers. Remember, always put them in least to greatest. The answers for these are 30, 40, 49, 52, 57. Okay, so this question said, what is the interquartile range? It says it right there. 20 movies. What percentage of movies are at least 130 minutes? Okay. Here's 130. And what did we say about what did I say about this? How this splits it into 25s? So 100, at least 130. So what would be that little block? 25, right? 25%. This says what movies are between 100 and 140. Well, 25 and 25 is 75. And you're not going to have, these are the ones you're going to have on the test. So I'm not going to worry about the other ones. I'm trying not to give y'all too much information because I know it's a lot to absorb. Just always remember these are split into 25%. So if it says what percentage of movies are 85 minutes to 140, well, 100% of them in this case out of the 20 movies that they observed. So, and again, if y'all have questions, message me and I will answer them. Okay, this question, it gives you a plot of Spartans and Eagles of their last 12 games. This says, which team had a greater range? What's range, guys? Biggest number minus the smallest. So this one, biggest number is 33 minus 3. So 30 for the Spartans. And for the Eagles, 40 minus 6, right? So 34. So the Eagles had the greatest range. The next question, what is the difference in their maximum score? You simply just take that number, 33 and 40. So 40 minus 33. 7 points is the difference in their maximum score. You know, I don't think you'll have anything like that. So we did not do the scatter plots and line of best fit. So I marked that out for y'all. And this is the last page. Hold on, guys. Okay. So, two-way tables. Says the Venn diagram below shows the result of a survey in which groups of students were asked if they have a cat or if they have a dog and if they have a cat. It says complete the two-way table. So it gives you a diagram and you have to complete it. So how many people have, so this is the people who have dogs, 16. This is how many people have cats, and this is how many people have both, and this is how many people have none, right? So how many people have a dog? Let's fill in this one. How many people have a dog and a cat? 12, right? Okay, how many people have a cat but no dog? 22, right? You see this line for the total. We will worry about these later. In every two-way table, you are going to have, sorry, you can't even see it. You're going to have, on this side, you're going to have something with the total, and then on the bottom, you're going to have something with the total. So Okay, how many people have a dog but no cat? 16, right? How many people have no cat and no dog? 10. Now all you have to do is add these up. So this is 34, this is 26, this is 28, 32, and then if you add all this up, 60, and that's how many people they would have surveyed, the 60 people. Okay, hopefully that makes sense. The next question says the partial table below shows the number of gold medals in women's, men's, and mixed team events by the United States in 2016 Summer Olympics. Complete the table, then answer the questions that follow. Okay, so complete the table. Let's look at the table. Again, we see the total and total. So, how could we complete this? Well, let's see. I see this one only has one missing. I see the total of 46. So these numbers should add together to get 46, should they not? These, they added together to get 34, right? So let's look at this. 18 plus 1 we know is 19. So 46, I'm going to say 46 minus 19 is 27. That's how many should go in this blank. Because when I go back and I add those numbers up, I should get 46. And I kind of messed that up. It kind of looks like 8 and 5 now, but that's 46. Okay. Let's do this one. This is going to be the next one we can do. Total of 55. So let's add together 18 and 19. We get 37. So 55 minus 37 is 18. So that's what needs to go in there. Okay, this is the next one we can fill in, right? You're going to fill in the ones first that only have one blank. And then once you fill in those, all the other ones will start to fall in place. I don't know if you've ever played, I don't know if I say it right, Sudoku, where you have, you can't put the same number in the same row. It's kind of like it. Okay, so let's fill in this one. 19 plus 2 we know is 21. So 21 or 31 minus 21. So based on this one right here, that one right there, 19 plus 2 is 21. 38 minus 21 is 17. So that is what should go right here. Okay, these are the totals. So these are already filled in, right? So I can go ahead and add those up. 27 plus 17 plus 17, 61. I can fill in this, right? Because 5's the total. 2 plus 1 is 3. So 5 minus 3 is 2. And then from here, it's just adding it up. So 18 plus 17 plus 2, 37. And to know you did the math right, this line should equal the same thing as this line. So let's see. 55, I'm trying to show you all my calculator. 55 plus 61 plus 5. Okay, and then 46 plus 37 plus 38. Same thing, right? All right, and so that's how you fill the table out. So fill in the one that only has one missing, like here, and then here, here, and then from there, everything falls into place. You just have to make sure that you look at what you're looking at. Don't, the total line's here, so don't get, those numbers confused with, oh, that's a bronze or, Okay, so the question, how many bronze medals did the United States win in the women's event? Okay, well, let's see. Women, bronze medal, 17, right? Sorry, you can't even see what I'm doing. So I went to, they want to know the bronze medal for the women's. So I'm going to look at the women, go over to the bronze, make sure I'm at the bronze, and that's the number. The women's bronze, 17. Okay, it says how many total medals were won? How many total medals were won? Well, there were 46 gold, 37 silver, and 38 bronze. And luckily, we've already added that up, right? 121. And I don't think there's one like that on the test. Actually, let me just double check because I want to make sure. I'm going to sit this phone down for just a second. My arm is. This is just going to take too long. I'm going to go ahead and do it anyways. So relevant frequency says to complete the table using this question on relevant frequency. So what you do is you simply just say, okay, so 18 is in this block. You were going to say 18 divided by the total number at the bottom, which in this case was 121. You get round to the, I think it said the nearest 100th. So that's this place. So that 8 would round that up to a 5. So 0.15. Okay, let's do this one. So 27 divided by 121. 17 divided, or 27 divided by 121. 22. It would round down. Okay, so I'm gonna go ahead and fill the rest of this table out. You can pause it and you can put a 0 in front of here. I'm gonna do it just because of this next problem. And this number at the bottom should always be 1 if you've done it right, because 121 divided by 121 is 1. And that's the table. This question, last 2 questions, guys. What percentage of medals won were in men events? Okay, well, let's look at the men events. Go over to the total. How do we get decimals to percentages? Because it's asking for a percent. We times this by 100, right? 45. 45%. This says what percentage of medals won were women's events. Women, 0.5. Oh, I was about to do it wrong. It says women's gold medals. Make sure to read the entire question because I was like, all right, 50%, and I looked over at the answer and I was like, no, that's not right. So women gold. Look at the women, look at the gold. 0.22 times that by 100 and it would be 22%. So guys, if you have a question, let me pin my video so you can see me. I just want to talk for just a second. I'm actually going to leave the link right there. If you have any questions, please message me. I know this was a little different because, again, I'm at home quarantining. So message me if you have questions. I know it was shaky. I forgot my document camera, and I really hate that. But just, I would say go look at your Unit 4 test/review. It's pretty similar. We've already did probability, and that's what the 9 weeks test is on. So I'd just go back after looking at this. I would probably just go do that review again, and that would really help. So if you have questions, message me, and that's it. So